So in chapter 2.4, linear equations and functions, our in-class objectives are to graph linear equations in two variables, determine the slope of a line passing through 2 points, apply the slope-intercept equation from a line, and then compute the average rate of change, and then finally we will talk about solving equations and inequalities. The major concepts in section 2.4 are the following. We're going to graph linear equations and find the x and y intercepts. So once we find the x and y intercepts, then we can graph our equations, and you will remember that when we find the y-intercept, we let x equal 0 in the equation. And then for the x-intercept, we let f of x equal 0. The slope of a line is calculated by the following. M is the slope, where we have y2 minus y1 divided by x2 minus x1. So in some sense, if we have a point x1 comma x2 and we have another point, oh, that's not right, is it? It's y2, y1, right? x2 comma y2. So those are our points, and we put them in the slope formula to get the slope. So also in this section, a line can be written in two forms, either standard form or in slope-intercept form. In standard form, it's just the coefficient a times x plus the coefficient b times y is equal to c. For the slope-intercept form, we have y, the variable y, is equal to the slope m, x plus b. B is considered my y-intercept. And then in the final stages of this section, we're going to talk about the average rate of change. And the average rate of change between 2 points on a function is just what we call a secant line. And so the average rate of change between 2 points is just f of x2 minus f of x1 divided by x2 minus x1. It's called the change in y over the change in x. That's the average rate of change. So in this section we're going to graph linear equations of two variables, and we have 4 equations here. We're going to graph the following. We have part A, B, C, and D. We're going to look at A first, and we see that it's in standard form. So the best thing we can do is we can use the x and y intercepts to graph, and we're going to do that next. So we'll do it for A first. So here I have A, and in this case, if I let x equals 0, we'll get the y-intercept. So we have 3y is equal to 6, y is equal to 3. So for our graph A, we have 3. 1, 2, 3, and we have a point there. That's where our y-intercept is. And for our x-intercept, we let y is equal to 0. So when y is equal to 0, we have 4x is equal to 6, or x is equal to 3/2. So our 3/2 in this particular case, if we go over 1 1/2, which is right here, we have our point for here, and so there is our graph for this particular, for problem A. So now I want you to pause and try B on your own real quickly. So pause the video and then repause it once you have the graph for B and see if we have the right answers together. So for B, our x-intercept, or x is equal to 0, so we're going to find our y-intercept. We get 2y is equal to 3, which means that y is equal to 3/2. So for problem B, we come over and we say, oh, well, y is 3/2, which is right here. I don't know whether I got it right or not, but there we go. And then we have y is equal to 0, which is going to give us our x-intercept. So we have a minus x is equal to 3, which implies that x is equal to a minus 3. So we come over to minus 3, 1, 2, 3. And now we have our line, which is going through the 2 points, and typically I try to get this as straight as I can. So that's what my line looks for B. And so again, I want you to pause and try for C. So for C, I'm going to let x is equal to 0 to find my y-intercept. I get a minus 2y is equal to 6. Y is equal to a minus 3. So this is going to be C. Y is minus 3, which is right here. And now we'll do y is equal to 0. So when y is equal to 0 here, we have 3x is equal to 6, which means that x is equal to 2. So you can see where we're finding our different intercepts here. And now I'll draw my line. Not very straight, is it? There we go. And finally, number D. So D is not, we only have a line at what? Regardless of what x is, y is at 2. So this line is horizontal, and it's just going in this direction. Now we want to determine the slope for a line through 2 points. So we recall that our formula for slope, again, is m is equal to y2 minus y1 divided by x2 minus x1. And so we'll apply the slope here for this function. So we get a minus 7 minus a minus 1 divided by 4 minus 2. And here I get, well, I end up with a positive 1, so I get a minus 6 on top, and I get a 2 on the bottom, and my slope is negative 3. So there's my answer for the first one. So now I want you to pause and try number 36, which is the next problem, and see if you get it correctly. So okay, by now you have tried the problem, so we'll do it here. M is equal to 6. Now I've reversed something here, so I'm going to pick a different point as number 2. So I pick the second one as number 2. But I have to be consistent with my x's and y's, right? So the x's and y's have to be over each other. And here I get 2 over 8, which is equal to 1/4. So the answer I get here is 1/4. Okay? Alright, so now we have the last problem, which I would like you to also do. This is problem number 41 on page 240. So go ahead and pause and see if you get the same answer that we will be coming up with. Okay, so this one is with fractions, and of course everybody loves fractions. So we're going to try this one. M is equal to 1 minus 6 divided by 5 halves minus 3/4. Right? Well, this is kind of ugly, so we're going to do some manipulation here. We know on top we have a minus 5, right? But on the bottom we have to get a similar denominator. So I'm going to put this as 10 over 4 minus 3 over 4. And now I get a minus 5 over a 7/4. And this is equal to a minus 20 over 7. How about that? So there's our answer, right? And if you want to put it in some sort of other terminology, you can. You can put m is equal to a negative 2 and 6/7. Or you can even put it in decimal places, but I would prefer maybe either one of these if you're doing it on paper, probably on this way. So now we're going to apply the slope-intercept form and find the slope and y-intercept. So you will recall the slope-intercept form is y is equal to mx plus b, right, where b is my intercept and m is my slope. Well, I have problem A in standard form, so I have to get it into slope-intercept. So what I'm going to do here is I have a minus 4y, and I'm going to move the 2 over, so that's a minus 2x plus 8. And now I'm going to divide through by a negative 4, so I get a y is equal to 1/2 minus 2. Oh, I'm not careful here, am I? So let's get this right. It's 1/2 x minus 2. Now I have it in slope-intercept form. I know what the slope is. It's 1/2. And the y-intercept's at minus 2. So for part A, I will find out, let's see, I've got a negative 2, so my graph is here, right? And so my next point, if I use the slope, I go up 1 and over 2. So my next point is right here. And my next point is going to be right here at 4. So that's where my x-intercept is going to be. And that makes sense, because if I solve this thing for 0, right, 0 is equal to 1/2 x minus 2, I see that 2 is equal to 1/2 x, and if I multiply both sides by 2, I get 4. So there is my line. My line is right here. Oops, I'm not very good at this, right on this machine. So there it is. There's what my line looks like. Now I want you to pause the video and I want you to try problem B and then graph it and see if you get the same answer as I will get. Okay, so now we will do the same thing as I did before up on A. I'm going to have a minus y is equal to a minus 3x plus 6. Now I'm going to divide through by negative 1 or multiply through by negative 1. It doesn't make any difference. In any case, I get y is equal to 3x minus 6. And so now we can also find the x-intercept, 3x minus 6, which means that 6 is equal to 3x. X is equal to what? 2, right? So we have a point at 2, and we have a point at negative 6. 1, 2, 3, 4, 5. Oops, 6 is way down here, right? So my line that I'm going to put through is going to be right, oops, right through here. Sorry. Okay, there's my line. I guess I should kind of erase, maybe I should erase this a little bit and try it all over again. So my point is at 2, and it's at negative 6, which is right here. Now let's see if I can draw the line straighter. Well, a little better, huh? A little jiggly there. Okay. So sometimes we will have a function and we're trying to find the rate of change between 2 points on a function. So in our first case, we have determined the average rate of change from negative 1.50 to 2, 0 on the graph. And we have those already pointed out. And so what we're looking at is we're actually looking at the secant line that goes through this point right here. And the average rate of change is the slope of that line. So we know how to find that, right? So the slope, or the average rate of change, is the change in y over the change in x, right? And we can find out what f of x2 is minus f of x1 divided by x2 minus x1, because that's our average rate of change. In this case, we see that 2 is the higher number, so I'm going to go ahead and pick that one. It doesn't matter actually. 2 minus 0, right? Because those are the y values. Okay. And then for the x values, I get 0 plus, right? Because a minus of a minus is 1.5. Right. So when I do this, I'll get a 2 on top, and I'll get a 3/2 on the bottom, which is equal to 4/3, right? So the average rate of change for this particular secant line in red is 4/3. So now we want to even move a little further here. Suppose I'm given a function and I want to find the average rate of change through a secant line for a particular point. So the next problem does that exactly. We have a function, f of x is equal to x squared minus 3, and we've learned already so far that that's a parabola. And furthermore, there's a secant line that goes through the point, through the interval x equals 1 and x equals 3. So we don't need to know the y points here. All we need to know is the function and the interval on which the secant line is passing through. So to do this, we do the delta y over delta x is equal to, and again we put in f of x of 2, right, minus f x of 3, or x of 1, right, divided by x2 minus x1. Here I was going to sleep here, so my monotone voice is not good. So how I will do this is I will put in f of 3 minus f of 1 divided by 3 minus 1. Well, what's f of 3? Well, I can do that. I can do 3 squared minus 3 minus 1 squared minus 3 divided by 2, right? Wow, lots of work, right? So 9 minus 3 is 6. 1 minus 3 is a minus 2 all over 2. And when we do this, we get a 6 plus 2, which is what? 8 divided by 2. And so our average rate of change is 4. That's the answer. So now what I'd like you to do is practice some of the problems that are in the book in this chapter on average rate of change. This is an important concept, and you'll be using this certainly in the calculus and the pre-calculus classes. So typically when we are solving equations or inequalities, we're looking at two lines that are either intersecting, and where they're intersecting, they're either greater than a certain point or they're less than a certain point. So I would like you to look at the first problem, which is number 101 on page 242 of your book. And you will note that in this particular case, f of x is equal to a negative x minus 3. And there's a graph in the book for that. I didn't want to put that in here. And also, there's a graph of g of x at negative 3x plus 1. And when those two graphs meet, we can solve that equation as an equality. So when we're solving equalities, we're finding just one point here. So in this particular case, we solve for x. We're going to get well, I'm going to bring the x's over to the right-hand side and the numbers to the left-hand side. And so I get 4 is equal to 2x, right? So x is equal to 2. So our solution set for this, for part 1, is just 2, right? It's just 2. Now I'm going to do an inequality, and so the inequality is slightly different because there can be a set of points that will actually work. So now I'm going to do the inequality, and I just handle it basically the same way. I leave the inequality alone, and so now I'm going to do the same motion. I'm going to get 4 but I'm going to leave the greater than sign, is greater than 2x, right? So now I divide both sides of the equation by 2, and I get 2 is greater than x. Well, what does that mean from interval notation? Can x be a negative number? Yes, because it is less than 2. In other words, we rewrite this as x is less than 2. So from interval notation, when we do this in interval notation, we're going to get a negative infinity, comma, 2 with the open end. Okay, so now let's look at problem number 103 on page 242. This is a little bit more complicated because there's a little bit more to it, but I would like you to pause the video and try the problem, the equality first, and then try the inequality next, and then write it in interval notation. Okay, so let's try the equality one first. We will note that we're letting f of x equal g of x, and we're solving for x. That's essentially what we're doing. So when we do that, we have to use the distributive property first. So we get a negative 3x minus 6 plus 1 is equal to a negative x plus 5. And now we're going to combine like terms. Obviously we get a negative 3x here minus 5 is equal to a minus x plus 5. So we're going to bring the x's to the left hand side. When I do that, I get a minus 2x is equal to 10 when I bring the 5 over to the other side. And now I divide by a negative 2, I get x is equal to a negative 5. Right. So our solution for the first one is in set notation, we just put a negative 5 there. So now in our inequality, we're going to have the same setup, except this time we get down to, right, we do the same ideas. We distribute, we get a minus 3x minus 6 plus 1 is less than or equal to a minus x plus 5. And again, we get a minus 3x minus 5 is less than or equal to a minus x plus 5. And so now this becomes a negative 2x is less than or equal to 10. Finally, we divide through by a negative 2 and we get x is greater than or equal to a negative 5. So when we write this in interval notation, we do have the negative 5 bracket, comma, infinity, right? So there it is. There's our solutions. So now we want to say what was learned. How to graph a linear equation using the intercepts. Determine the slope of a line passing through 2 points. Applying the slope-intercept form of equations and graphing. Compute the average rate of change of 2 points on a function and solve linear equations and inequalities. I'd like you to continue to do some problems in chapter 2.4 and also go through the lecture problem notes.